Something's burning down today in Berlin, and I take the opportunity, I'll take the chance to explain people something about gravity. What makes the smoke rise up? Look at those. It's mesmerizing in a way. Of course, lucky I'm not the owner of this place, but it's mesmerizing to see, to watch it, how the smoke evolves in the sky through the air as it's rising up. Why? Because of gravity. Because of gravity. So there's a force going upwards, which is also gravity. Why is the smoke rising up? Because particles are lighter than air, and most likely there's a fire underneath the smoke, which of course creates thermodynamics. That means hot air rises up, creates this sucking motion upwards, and then basically the particles that are burning down from whatever is burning down, these particles are being dragged upwards, and that's basically smoke. Okay, what drags them upwards is the thermodynamics of the heat underneath also, and then as well the fact that smoke is a little bit lighter than the air, but also in the background you can already see that the smoke is coming down again, because the particles are then, of course, everything is being dissolved in air, and then particles that are darker are coming back down through the air, back down to the ground, all because of gravity. And then the heat again of the actual source of the fire is producing this updrift, and it's dragging those smoke particles upwards along. You see that again? Okay. It's all because of gravity. Smoke is rising up. Okay? Gravity is not just pulling down everything. There's a direction now going on that is pointing upwards, and the smoke is slowly disappearing. Well, it's almost the end of it. I guess they're distinguishing the fire now, but it was a great example that just happened randomly to illustrate how gravity actually works. How gravity can also pull things upwards, because there are forces involved. Okay, for example, thermodynamics, heat, hot air is rising up because heat is vibrating air, fast vibrating air rising up, having less density than cold air. And that is also a reason why smoke is rising up. Smoke is basically the particles, dirty particles in the air that are being lifted up through the heat. And then at the end there you can see that behind the smoke, or the particles are dissolving in the air, but they are coming down again. Okay? Because there is no heat source underneath it that would drag them up again. And so cold air is basically pressing them down, pushing them down again. And not just cold air, but the particles itself, they have a higher density than the air, and that's where they're coming down. And everything that is lighter than air is rising up through the air, such as helium. for example. Of course, here there might not be helium involved right now. It's basically just the heat of the fire and a few other materials, I don't know, nitrogen, chemicals. Hydrocarbonates that are rising up as material is burning down. And it's funny that Einstein's theory, the relativity theory, was like groundbreaking back in the day. Although, to me, or to most people, I think it makes sense that if you, for example, burn wood, then the mass of the wood reduces because something is going from the wood into the air. Okay, but back in the day it was somehow groundbreaking, and the only thing that Einstein did was make a formula to this, describing it with a mathematical formula that mass is reducing when mass is shifting energy or transforming energy, and that's all. I mean, it's common sense that if you burn wood, then at the end of the day you're left with no wood, or almost no wood. It's just some ashes on the ground, but the wood is gone, so mass has changed. Okay, so this whole thing about Einstein's theory was relativity, was about mass, and that energy is linked to mass, and that if you have a mass that gives off energy, the mass is being reduced. The same way you, for example, light a piece of wood on fire, and then that piece of wood is slowly reducing in size because mass is given away. Okay, mass is given away from the wood. Other chemicals or chemicals that were bound in the wood are leaving the wood, and so they all have mass. And when mass is leaving mass, of course, the source of the fire is reducing. And the same with oil lamps, for example. You have to keep fueling an oil lamp with oil because the oil is burning down. The mass is getting reduced because the mass is being transformed, or the oil is being transformed into other chemicals that rise up through the air, also because of heat, because of thermodynamics, but also because they are chemicals that are less dense than air. And so it's rising up, and what you see, for example, as a flame is also interesting, is plasmatic material. Plasmatic material, that's what is producing the light, or the color of the flame is basically plasma for a short time, while the chemical is rising up through the air from the wood up into the air. It has a few seconds, milliseconds of a state of plasma, okay, and that creates light, a visible light that has colors. And the less, or let's say the cleaner the burning fuel is, the less color you get, the more it will be a clean flame, like bluish, close to invisible flame. You get those gas burners, you don't really see the flame simply because there's almost no material, no dirty material, sort of, that's how you can imagine it, no dirty material that is burning and that could create a color. So again, you have fuel, you have a source like wood. Wood is burning because of heat. then parts inside the wood is transforming into other material, so the wood is losing mass and the flame is rising up through densities, because the chemicals that are being released are less dense than the air, so that's why every flame points upwards. All of this because of gravity. And then at the end of the flame you have the particles, like smoke or something, that is going up through the air because of thermodynamics. And yeah, if there are a lot of particles, like with wet wood or something, then you get a lot of smoke, and the cleaner the fuel is, the less you will actually see the flame. Although, I mean, or the clearer it also gets that the flame is basically just energy. It has pressure, upward pressure. Mass is pushing upward, okay? And that's all part of gravity, because gravitas is Latin and it means weight. And it's linked to mass. Weight is linked to mass, but again, mass and weight are not one and the same thing. The difference between mass and weight is that mass can always stay the same. An object has a certain mass, can always stay the same, but the weight that you're measuring depends on the surrounding medium. So that means if you have a stone, it has a certain mass, but surrounded by water, it will weigh less than surrounded by air. Very simple. Or surrounded by sand, it will even weigh less. It will be, if you have a stone inside of a sand box, it's weightless, although it has the same mass. You see what I'm saying? It just stays there, unmoved. The same, a human body is weightless in water, or a fish could be seen as weightless in water. It just stays there if it doesn't move. All depending on the surrounding medium. And that's buoyancy as well. So you can rewatch the whole video. It was quite nice that there was this smoke appearing to explain a little bit about gravity and how gravity is not just pulling down, but it's also moving upwards. Gravity is describing a direction of force. It's a result. It's a term with which we describe this play of forces, that sum of forces that is coming together and creating direction, either upward, downward, or to the sides. It's just a result. Okay.